The thesis that I'm doing, at least the working title of my thesis, is The Past, Present, and Future of Quantitative Diagnostics. When you go as a patient to your physician's office, sometimes they take blood, they take urine sample, and they send that blood or urine sample off to a laboratory to have various tests performed on what is present in your blood or urine and how much of that material is in your blood and urine. That's kind of the area of quantitative diagnostics. Not surprisingly, those have a history, and the history is sort of complicated. Some of that history involves the history of immunological chemistry or immunology in itself. Some of that has to do with colorimetric chemistry, which is the quantitation of amounts of color in a specimen. And some of it, some of the more specialized testing has to do with gas chromatography, mass spectrometry. So each of those technologies has a past, a background. And in fact, the general area of quantitative diagnostics probably goes back to just the way that we perceive things. We hear things, we see things, we make an evaluation, although qualitative, of the health of the patient. This has probably been done for as long as human beings have been on the earth. If you're living in a community of other human beings, some of the human beings can tell when one of their community members are not doing well. And they can tell that by the color of their flesh, the color in their eyes, their breathing, whether it's rapid, whether it's shallow. They can tell by listening to the heart or feeling a pulse. All of these things have an element of quantitation in them. Quantitation, of course, didn't come along for much longer, until much later. But generally speaking, all of those methodologies have probably been around since the dawn of mankind. So my interest, and this tends to be generally true for me, I tend to look at the most basic start of human knowledge. How did we get to the point where we are now? How did we get to using the technologies that we use to perform diagnostic chemistry and determine whether someone is healthy or whether they're not doing as well as they might do or whether they're quite sick? And this interests me because it's basically similar to an area that I worked in the pharmaceutical industry for 35 years or so. And so it's sort of a natural fit for me. Thinking about it in a historical sense is something that I never really did while I was working in the field. Now that I'm retired, I have the time to go back and look at these things in a much more organized and precise way and look at the roots of how all these different technologies came into existence. So I'm looking back as far as sort of early anthropology of humankind. What was it? What were we initially, and what might have health looked like in those first people? Because I think that state has probably been in existence for our entire existence. However we were when we were hunter-gatherers wandering around in some unknown area, in some unknown environment, surrounded by different creatures, surrounded by different plants, different water sources, different food sources. That condition is probably very similar to the condition we find ourselves in today. The big difference is that we've grown a whole set of technologies to help understand what the nature of health is. We can get at some numbers which we can then track over the course of someone's lifetime and try to understand when those numbers deviate from that person's normal values into areas which are more problematic. For instance, if someone's blood glucose level goes up to a certain higher level, then that's usually an early indicator that diabetes might be a concern for that individual. What the physician wants to do, given the information they have received from quantitative diagnostics, is they then want to return those values into a general normal range. So the whole area of general normal ranges is also part of this history of quantitative diagnostics. Before there were quantitative diagnostics, no physician on the earth could have told you what a normal glucose level might be for a person and when it got to a point where they were in danger of developing diabetes. So how was that whole basis of understanding of blood glucose, for instance, developed over time? First of all, we haven't always had numbers. We haven't always understood how to understand a set of numbers, which is basically the study of statistics. In statistics, you get into areas like the range of numbers, whether those numbers fall within plus or minus one standard deviation of a mean value, or whether they are more plus or minus two standard deviations, or even further outlying the mean than even plus or minus two standard deviations. So all of these types of criteria apply when you receive a quantitative diagnostic result from your physician, who has in turn received it from a specialty laboratory that works through these kinds of tests. And for me, all of that is very interesting. It's a more modern, more precise and accurate way of determining human health than could have ever possibly been available to our most ancient ancestors or even recent ancestors. Now, at the same time, there are implications to how that information is used. So I am interested also in how the physician shares that information with the patient, and I'll be doing some questionnaire work to look at that topic. And there's also the issue of how that information, how the use of that information and how obtaining that information from samples is regulated by various national organizations. In the US, it's a study or a set of laws called the Clinical Laboratory Improvement Act, which is established by Health and Human Services, but it also gets into an area that the Food and Drug Administration regulates, in that very often those values are used in the approval or the dismissal of a new drug application, which comes from a pharmaceutical company. And this gets into an area that I've worked in for 35 years, mostly working with clinical pharmacologists in phase 1 through phase 4 drug development trials.
Se você gostou desse vídeo, dê um like, compartilhe. Aproveite para assinar o canal e ative as notificações.